Welcome back, dear students, for today's class. Last class, we discussed about torque acting on an electric dipole placed in a uniform electric field and the potential energy of the dipole in the electric field. Today, we will do some numericals based on these two topics. So we derived the equation for torque acting on a dipole placed in a uniform electric field. What was the equation? Torque equals PE sine theta. This was the equation. So I will give you a question. An electric dipole of length 10 centimeter. Question. An electric dipole of length 10 centimeter having charges 6 into 10 raised to minus 3 coulomb. Placed at 30 degree. With respect to a uniform electric field. Experiences a torque of magnitude. Torque of magnitude 6√3 nanometer. 6√3 Newton meter. Calculate 1 magnitude of electric field. And 2 potential energy of electric dipole. So students, first you have to read the question, understand it, and write the given data. Okay? And you elicit the formula for it, apply the formula, calculate. These are the steps for doing the problems. So dipole length is given. So 2A is given 10 centimeter. You have to convert it into meter. 10 into 10 raised to minus 2 meter. What else is given? Charge is given. 6 into 10 raised to minus 3 coulomb. Placed at 30 degree. Theta is 30 degree. Torque given 6√3 Newton meter. You need to find out the electric fields. So you know the equation connecting these quantities. Torque equals PE sine theta. P is Q into 2A. E sine theta. Torque they are given in the question, 6 root 3. Q also given, 6 into 10 raised to minus 3. 2a is given, 10 into 10 raised to minus 2. E you have to calculate, theta given, sine 30. So it is very easy calculation. You can find out E. You can cut this 6. Sine 30 is 1 by 2. You calculate E. You will get E value as 2 root 3 into 10 to the power 4 Newton per coulomb. So this calculation is easier one, direct formula application. What is the second thing? Potential energy of the electric dipole. Equation for potential energy, you know, U is equal to minus P cos theta. U is minus P cos theta. So just apply the formula. P is Q into 2A. It is given. E into cos 30. So what will be the answer? U equals Q 6 into 10 raised to minus 3. 2A 10 into 10 raised to minus 2. E you calculated 2 root 3 10 raised to 4. Cos 30 is root 3 by 2. When you calculate, you will get it as minus 18 joule. You have to do the calculation your own. Okay. I will give you one more question. All the numericals you have to practice many times. Okay. Numericals, derivations, children always learn by writing. Otherwise, you will forget it. You won't be able to write for the examination. I will give one more question. Two small identical electric dipoles AB and CD. Question. Two identical electric dipoles AB and CD. Each of dipole moment P are kept at an angle of 120 degree as shown in the figure. What is the resultant dipole moment of this combination? If this system is subjected to an electric field, directed along x direction, what will be the magnitude and direction of the torque acting on it? So this is a question. So here diagram is given. Two electric dipoles, diagram given. This is one electric dipole. Charges are plus Q minus Q. This name is CD. CD. One more dipole is given. That is kept like this. This is AB. Charge Q, A, charge minus Q, B. So angle between these two is 120 degree. 120 degree. And the x direction given. X dash. So you have to find out the dipole moment. You know, dipole moment is a vector quantity. So two dipole moments are given and angle between them is given. So you know how to add two vectors. So first dipole I am drawing here. First dipole is this one. This was CD. Okay. Another dipole AB. One minute, I will draw again. See, this was AB. AB. The second one is CD. Okay. So angle between them is 120 degree. So when two vectors are inclined at an angle, how you can find out the resultant? There is an equation. What is the equation for resultant of two vectors? You have learned the parallelogram law of vector addition. This diagram is wrong. So this is the AB, dipole AB. Then dipole CD. This angle is given 120. Okay. So two vectors inclined at angle 120 degree. What is the equation for resultant? You know this equation. Resultant is equal to root of a square plus p square plus b square plus 2ab cos theta. Root here identical dipole moment. P square plus 2p square cos 120. Root of 2p square plus 2p square. What is cos 120? Cos 90 plus 30. That will be minus sin 30. So minus 1/2. So the answer will be P. So this is the resultant dipole moment. Okay. And what will be its direction? You know, the two vectors are equal in magnitude. So its direction will be 60 degree, right? Half of that, because they are same. So it is 120 degree, 60 degree with either of the vectors, making 60 degree with either of the vectors. Okay. Then, what is the second part of the question? You have to find out the magnitude of the torque, magnitude and direction of torque. Listen, electric field is along x direction. This is x dash. What is the angle between electric field and the resultant dipole moment? This will be 30 degree. So you can find out the magnitude of torque. Second part of the question, you need to find out magnitude of the torque. How will you find out the magnitude of the torque? The equation you know. Tau equals P sin theta. Resultant is P only. E sin 30. So P by 2. Sin 30 is 1/2. Making 30 degree with the x direction. Okay. What is the direction? Making 30 degree with the x direction. Okay, children. Then we will do one more question based on electric field. One more question based on electric field. 2 point charges (4q and Q are separated by a distance of 1 meter in air. Distance of 1 meter in air. At what point on the line joining these two charges, line joining the charges is the electric field intensity 0. Okay, so you need to draw the diagram first. So you visualize the question first. 2 point charges. So this is 1 point charge, 4Q. Another charge is Q. Distance between them, it is given as 1 meter. What is the question? At what point on the line joining the charges is the electric field intensity 0? See, if you take a point in between, the charges, take this point P. This is at a distance x from 4Q. You know, electric field due to the 4Q charge is at P is away from the charge. It will be in this direction, say E1. And electric field at the point P due to the other charge Q, that is also positive. It will be away in this direction. So the fields come opposite direction along the in between the lines. But if you take a point outside, electric field due to first charge is in this way, second charge also in the same direction. So electric field will be 0 at a point in between the charges. Okay, now you have to find out that. So from the charge 4Q distance is x. So from the distance from the charge small q to the from the charge q to the point P is 1 minus x, right? Remaining distance. Now you can, this should be equal. These E1 and E2 should be equal and opposite. Then only net field at the point P is 0, right? So we can write at the point P, E1 equals E2, right? What is E1? K Q1 by x square, E2 K Q2 by the remaining distance, 1 minus x square. You can cut K. Q1 is 4Q divided by x square. Is equal to Q2 is Q by 1 minus x square. Cut Q. So if you rearrange, what you will get? 1 minus x by x the whole square is equal to 1 by 4. Right? So 1 minus x by x is 1 by 2. So you can cross multiply now. 2 into 1 minus x is equal to x. So 3x is equal to 1. X is equal to 3x is equal to 2 here. 2. So x is equal to 2 by 3 meter. So the electric field is 0 at a point of 2 by 3 meter from 4Q. At a 2 by 3 meter from 4Q. Okay, dear children. So today I will stop the class. We will see in the next class. Thank you for watching.